Hello, my dear students. After a long time, I am too much busy and couldn't give you the initial lectures on video engineering lab. But the first experiment, radio engineering lab 1, the name of experiment is observation of high frequency small signal tuned amplifier circuit. So, first we have to discuss the theory of the high frequency small signal tuned amplifier. So here you can see uh, high frequency small signal tuned amplifier circuit. So the thing is that high frequency small signal and tuned amplifier. So first of all we have to know what is the tuned amplifier. As far as we know, the types of amplifier that we have discussed so far work effectively at radio frequencies, even though they are good at audio frequencies. That means that previous some amplifiers, they are not usable in radio frequencies, so that's not usable in radio engineering. So if you want to make it usable in radio engineering, so first of all you have to make a tuned amplifier circuit uh, which will be usable in radio frequency and usable in radio engineering. Also the gain of these amplifiers is such that will not vary according to the frequency of the signal. That means it should have to be vary due to frequency of the signal over a wide range. Okay, so the gain should have to be changed by the frequency. This allows the amplification of the signal equally well over a range of frequencies and does not permit the selection of particular desired frequency while rejecting the other frequencies. That means a baseband signal. So an amplifier circuit along with a selection such as tuned circuit makes a tuned amplifier. So previously we know some of the BGT that makes the amplifiers. Amplifier means uh, the output should have to be greater than the input. That means the gain will be increased. So tuned amplifiers are the amplifiers that are employed for the purpose of tuning. What is tuning? Tuning means selecting. That's the first word we have to keep on our mind, that tuning means selecting among a set of frequencies available. If there occurs a need to select a particular frequency, that means if we want to select a particular frequency while rejecting all other frequencies, such process is called selection. I can draw a frequency set. Here you can see in resonance circuits that you have taught earlier in electrical circuit 2, you know that if it is frequency versus current or voltage curve, that is known as frequency response curve. In resonance circuit, the frequency response curve is like that. That means there's an upper frequency, there's a lower frequency, and an upper frequency. So lower and the upper, and middle of that is known as the resonance frequency. That means FR. So selection criteria means that will rely between these two bandwidths, between these two frequencies. That means if it is a FL and if it is FU upper, so that will be FU minus FL with bandwidth, BW bandwidth. So that is the thing, that such a process is called selection. Okay, we can reject this one and that one and just connect this, so that will be a process of selection. Now that is the basic circuitry of LC circuit. LC circuit means inductor and capacitor circuit. Here you can see L for inductor and C for capacitor. LC circuit, basic circuit, and that is also known as the BJT circuit. That is BJT has been used, transistor has been used here. This amplifier is a tuner circuit and called as a resonant or tank circuit. Okay, that's the tank circuit or tank coil. Okay, it selects the frequency. That means it selects the frequency And a tuned circuit is capable of amplifying a signal over a narrow band of frequencies that are centered at resonance frequency, as we know in our previous lectures. So that is the basic circuitry of a tuned amplifier. Now coming back to the point, in this part, this is the important two equations. The tuned circuit is capable of amplifying a signal over a narrow band of frequencies that are centered at resonance frequency. When the reactance of the inductor balances the reactance of the capacitor in the tuned circuit at some frequency, such a frequency can be called as resonant frequency. It is denoted as FR. And the formula of resonance is like this: twice pi FL, 1 by twice pi FC. That means if XL is equal to XC, XL means, you know, in resonance in resonance circuits, XL is the impedance of the inductor, and XC is the impedance of the capacitor. And if this is equal, that will be known as a tuned circuit or resonant circuit. After that, you can get this equation L and C. If you want to design this kind of frequency tuned circuits, so just put the value of L and C that you use here. Okay, so that's the main function of tuned circuit. Okay, and in here we can see that in up above there is a tuned circuit. VCC is there, C and L is there, and in that inductor we get the output of tuned amplifier in LC circuit. Okay, how the operation turns in: if the input signal goes through there, it's a circuit of our, that is in base we use the voltage divider circuitry R1 R2 Bjt, and that's LC part. VCC is there, and then you will get the output through there. So sinusoidal input, you will get a bigger sinusoidal output here, and that is, in that case the L is here. That means that will transmit through the electromagnetic wave, will be transmitting through there. Okay, so the radio signal will pass through this tuned circuit. Okay, as the inductor is open. So first of all, there are types of tuned circuits that you have to know. Series tuned circuit, that means L and C are in series, V in is in L and C is in output. And there are parallel tuned circuits as well. The parallel circuits as well as like this. In the previous circuitry we have used the parallel circuitry. And also the characteristics of parallel tuned circuit, we know the impedance. This is the characteristic, the supply voltage divided by the line equation. We can get this. That is the most derived and known frequency response curve according to impedance. And I have told you in earlier lecture, in the previous lecture, in the previous part, that's the line current. You can find out the line current like this. That is the equation that it governs the equation in parallel circuitry. And after that the circuit goes on. And I have also, if you know the quality factor means the XL divided by R. That's like this. The ratio of inductive reactance of the coil at resonance is to its resistance is known as quality factor. That means the sharpness of the resonance curve determines the selectivity. So the higher the quality factor, the curve will be sharp. That means this high quality factor. This is the low quality factor. That means the selectivity is high, low selectivity. Okay, that's the thing. And the smaller the resistance of the coil, the sharper the resonance curve will be. Okay, that's all to the basic tuned amplifier circuits.